Well, hello and welcome to AB Does Geography. So I look a bit different today because I've been on an expedition with Sir Dave, who you can see in the background there with his VIP badge. And what we were doing, we went on an expedition to investigate rivers. And that's what I'm going to be looking at with you today, which will be part of paper 2. Okay, so I've already covered the physical landscape, I've covered coasts, and we're looking at river processes and pressures. And again, look, it's only worth 7 marks. However, you will then have an 8 marker that will combine the core themes that run through this first section, which are rock type, precipitation patterns, so the fact that it's wetter on the west and north of the country, but most people live in the southeast, and the key concepts of erosion, deposition and transportation. Okay, so they're the key things. So what you're doing is not being asked to describe in detail the formation of an oxbow lake or a levee or a meander, but what you would be expected to know is which key process they are most likely associated with. So rivers, okay, so the key concepts in rivers is to understand how erosion, transportation and deposition change the shape of the channel and create distinctive landforms on the course of the river. So from its source in the highland or in upland down to its mouth where it joins the sea. And as the river goes on its journey, its channel shape will change, and also the landforms that you see in the upper course, the middle course and the lower course will also change. They are distinctive and they will be directly linked to one or all of those 3 processes. Okay, so you may be asked to describe the course of the river, so how the valley changes and the landform. So how does a river change from its source to mouth, so on its journey downstream, that sort of thing. And you will be asked to consider the role that various factors play in that. Then the more important part of this unit really is the understanding of how physical and human factors affect flood risk, which is something that we're very, very concerned about, aren't we, Sir David? Yes, we are. And also how flood hydrographs can be used to predict how a river will respond to a rainfall event. And then finally, a section on hard and soft engineering. Okay, so the first thing we're going to look at is how that river changes with distance downstream. So at the top here, we have what's called a long profile. It says longitudinal, it's a long profile. So what we've done here is we have plotted the distance from the source to the mouth against the altitude above sea level in meters normally. Okay, so this is the source, it's up in the hills or mountains, or might be in the mountainous areas of Wales, for example. And we know that water travels downstream under gravity, so it makes its way downwards until it reaches the sea, which is the mouth. And as it goes along its journey, it picks up more water, and that gives it more energy and more strength, and that's why the landforms change as you go along. So you get distinctive landforms associated with each part of the journey, the upper course, the middle course and the lower course. Okay, as the river moves downstream, it will pick up material. That material will get eroded smaller and smaller through the process of attrition, and that's why it goes from possibly being rolled along the bed, which is traction, bounced along the bed, which is saltation, to actually being much smaller, and it can travel in suspension or even in solution. And that's why a river will look muddier near the lower course. It's not dirty, it's not nasty, it's not smelly. What it's got is a lot of material that is now so small it is like floating along on its journey towards the sea. Look at how the shape of the valley changes. In the upper course, it's a V-shaped valley, big angular rocks called lode in here, so V-shaped valley. Then as more water gets into the channel, it starts getting more U-shaped. Be careful, don't confuse that with glaciation. Okay, but it gets wider and deeper because the river can erode laterally, sideways, as well as vertically downwards. And then eventually in the lower course, it's a much flatter shape. But again, don't be confused about the fact that because it's flatter, it's shallower. It isn't, okay? It's much shallower here, then it gets deeper, then it's very deep. So it gets wider and deeper with distance downstream. And the greatest misconception of all is it is much faster in the lower course, because here there's a lot of friction, which slows it down even though it's on a steep part of the course, whereas here we've got a lot more free flowing water and therefore it goes faster. Okay, so how does the channel shape change with distance downstream and its load? So it goes from being quite large to smaller to possibly being just floating along in suspension. Now you do need to be familiar with some landforms, distinctive landforms. So in the upper course, distinctive landform would be a waterfall, which is where hard rock sits on top of soft rock. The water will erode the soft rock quicker and undercut the hard rock, which will eventually be left as an overhang, and that overhang will collapse and the rocks that land in here will be churned around and that will form a plunge pool. So it erodes a plunge pool. This is a landform of erosion, and the waterfall retreats. It goes backwards as this happens over and over again. You will also see a V-shaped valley and interlocking spurs, but the main one will be a waterfall. In the middle course, the river starts to meander, and the water is always thrown to the outside of the bend, like this, always to the outside of the bend, and therefore you've got faster water and erosion on the outside of the bend, slower water and deposition on the inside of the bend. It is much deeper on the outside of the bend, and you can see that over time this erosion will bring this part of the meander closer and closer together till eventually the neck of the meander, they call it the neck, is cut off, leaving an oxbow lake behind. And this is a result of both erosion and deposition, isn't it, Sir Dave? Yes, it is. And then in the lower course, the most common landforms you will see there are levees, which are these little natural banks that build up due to repeated flooding. As the water flows over, it loses speed and deposits its load, creating these natural banks, and either side of those banks you've got the floodplain. Okay, and that's the primary process at this stage, is deposition. So what you are aiming to do is link your knowledge of process, erosion, transportation and deposition to the landforms that are distinctive at each part of the journey downstream. So we move on to think about flooding. Why do rivers flood? Well, there are a multitude of reasons, aren't there? And some of them are human reasons and some of them are physical reasons. And you will be expected to identify. Two will do, everybody. So when you're thinking about the physical reason, it might be prolonged intense rainfall. It might be steep land, which means the rain has got into the river quicker. It might be an impermeable rock type like granite, so the water doesn't infiltrate but instead runs over the surface and gets into the river quicker. Anything that gets the water into the river quicker will lead to flooding. Human causes, things like deforestation, which again, trees and vegetation slow the journeys, the water getting into the river, it slows it down. Like the raindrop takes longer to get into the river because it is either intercepted by the trees, so caught by the trees, or the trees absorb some of the water, so it slows it down. And the other important human one is urbanization, so replacing natural vegetation with impermeable surfaces like tarmac and concrete, and obviously channeling the water through drains into the river really, really quickly. So over here we have a flood hydrograph. You wouldn't get an 8 marker on this, but it is worth understanding how they operate. You have time along the bottom here. Look, day 1, day 2. It goes up in 2 hours each time. And what you do is a bit like a climate graph. We've plotted the rainfall on this side, but you read it against over here. So this is the amount of water that fell as rain, precipitation in millimeters. And then you plot the discharge. and the discharge is in cubic meters per second. So the amount of water passing through a particular point in the river per second. Okay, so it's not quite speed, it is about the volume of water, cubic meters per second. So we can see here that the river's quite low. Okay, there's not much water flowing through this point down here, but then it rains, and rapidly the amount of water going into the river increases, therefore its speed increases, and this is the peak point, the peak discharge, the point when the amount of water passing through a particular point is greatest. The difference between the peak rainfall and the peak discharge is the lag time, which is the time it takes for the river to reach its peak after the peak rainfall. Okay, the shorter that time, the quicker the river is likely to flood, and it's described as being a flashy river. And then the falling limb is the river responding and going back to its normal levels after the event. I've included a case study here. Please go to any site that you want and have a look at the Somerset levels, or pause this here and maybe make some notes about why the floods were so bad and what the impacts were. Okay. Finally then is, what can we do to protect ourselves from flooding? And you've got examples of hard engineering. We can do man-made levees and embankments, so made of concrete, for example, or other materials that would raise the banks, so keep more water in the river. We can build flood walls, and we can use dams to hold back a river as well and create a reservoir. You can also straighten the river, so get rid of the meanders so the water gets to the sea quicker. And a soft example, soft engineering, afforestation, so planting trees, and also this is floodplain zoning, where you recognise that there's a part of the land near the river that is risky, so don't build on it, maybe have some farming there, and because you know when the river's going to flood, it gives you time to take your animals away, and then that will eventually go back to being dry once the river flood recedes. So that is rivers, and I will now go on to make you another video for the human part of this paper.